Hey guys, today we're going to do a virtual lab on the relationship between force, mass, and acceleration. So up to this point we've had objects that have been accelerating, and so now we're going to look at what causes that acceleration and how the acceleration and mass work together when they have a force applied to them. So we're starting off with Newton's second law, force equals mass times acceleration. Okay, and so today we're going to just study how mass and acceleration affect each other. So we're going to have a constant force, and we're going to increase the mass, and then we're going to see what effect it has on the acceleration. Okay, now you probably have a good guess of what's going to happen, that as you increase the mass, we should see a decrease in the acceleration. So we want to collect some data to see that. So we have these little dune buggy cars, all right, and they look something like this, and they're different colors. All right, and then what we'll do is we'll take that little car and we'll pull it back, and it will apply force, and it's going to travel 1 meter across the floor. So it's going to travel 1 meter of distance, and what we're going to do is we're going to record the time. So you will need a timer to record that data and see how much it goes, okay? So the data you're going to be collecting is mass and time. And from the time, we will calculate the acceleration. So you're going to need to create a data table that looks like this. So you're going to start with the empty car, and you're going to do 3 trials. You'll then average those times together, and then you'll use the time to calculate the acceleration. Now, let's take a quick minute to look at that. So we know that the distance an object travels is dependent on the initial velocity times how much time it takes to travel that, plus any acceleration that the car has done, plus the time squared of how much that acceleration has occurred. So the initial velocity of our car is at rest. So the initial velocity is 0. So we can remove that, and we get the distance the car travels is equal to 1/2 the acceleration times the time squared. Using a little bit of algebra, we find that the acceleration of the car is equal to twice the distance it travels divided by the time squared. Okay? So this is the formula you're going to use to calculate acceleration. Be sure to record that on your paper. Now, the average time is what goes in the formula, and then we end up solving for the acceleration. So we'll do that for the empty cart, and then you'll do that with 20 more grams, and you'll do that same data there. You'll do 1, 2, 3, average it, and get the acceleration. With 40 grams in the cart, again, you'll do 1, 2, 3 trials, average, and calculate the acceleration. And then you'll do with 60 grams, 3 trials, average the time, and get an acceleration, okay? After you collect that data, so the way you're going to collect that data is you're going to see a video of us running the cars, and what you're going to see on that is you'll see a little card that says trial 1, trial 2, and of course trial 3, and so that should help you keep up with it. We may have missed 1 or 2 of those trials, so just carefully watch the video to make sure you're on the right spot. You'll see a card that says with 60, so these would be the runs where your data goes for the 60. You'll see a card that says with 40, so forth, and so on, the mass of the empty car. So you can get that data from there. The other thing you'll see in the video is you'll see us pointing to ready, set, go. So you're going to actually do the timing from home. And so you're going to have your stopwatch ready, and we're going to be ready, set, go. And you start the timer when you see us point to go, and you stop your timer when the car passes the end of the meter stick. And you'll repeat that 3 times for each data. After you collect that data, you're going to make a graph. Okay? You're going to make a graph of mass on the x-axis and acceleration on the y-axis. You want to draw a line of best fit, and you want to calculate slope. And the last thing you want to do is you want to do a CER based on what your graph and your data says. And your claim evidence reasoning should refer back to, if I increase the mass, what happens to the acceleration? So please be sure to calculate all this data and get your graph together, and then you can submit that through the classroom. Thank you, guys. Just move that card ready.